All right, everyone. Welcome out. I'm going to be taking a look at a data set here that I found on Kaggle and seeing if I can get some insights from this. This is a global tech salary data set here. We've got a lot of information about different salaries for different levels of experience, work year, where the employee resides, remote ratio, company location, company size, a few things like that. I've already got this downloaded locally on my machine. Just as a couple of notes here. I don't think it says it here, but I've already looked up, and there's about 5,000 rows of data in here. And these are all mostly data science related job titles here. But what we're going to do with this data set is we're going to use pandas, NumPy, and some visualization libraries, and see if we can get some insights out of this. Okay, let's jump into it here. I'm going to go ahead and set up my environment. I've been liking UV lately as my Python package manager virtual environment. So I'll go ahead and create a new directory called gtech salaries, and let's go ahead and cd into it, and we'll go ahead and turn this into a UV. Let's see, why is that not working for me? Okay, I just needed to source my Z shell config there. All right, so that creates a lot of files for me. And let's go ahead and add some Python libraries that I know I'm going to need. I'll need NumPy, pandas, matplotlib, seaborn, and then we're going to be running this in Jupyter through VS Code. In order to do that, I need a module called ipykernel. Let's go ahead and start with those. Boom, virtual environment's created. And I'm off to the races here. Let's go ahead and open up my VS Code window here. And then just on the off side over here, I'm going to grab this data set and drop it in my project here. Looking at this, you can see it's in the CSV format. It is actually a TXT file extension right now. We'll just go ahead and change that. All right, and then this project, it comes with a few files already in place. I'm just going to go ahead and create a file called salaries.ipynotebook, and let's go ahead and get started. I'm going to go ahead and import some modules as PD. This is the convention here as NP, and we'll go ahead and run this cell. It's going to ask me what environment I want to use, and then as a result, I'll have to run that cell again. This takes a little bit of time after I first activate that virtual environment. These imports usually don't take too much time at all. Okay, so I got my environment set up pretty good here. Let's go ahead and just let's go first. First things first, got to import that data set. I'm going to, most of the time the convention is to refer to the data frame as DF. I'm going to go ahead and call it salaries. And Pandas has a nifty little read CSV. It can read all sorts of different file types. Today we're just going to be using just this CSV. And let's go ahead and look at it. You can that's one of the handy things about Python notebooks, Jupyter notebooks, is that you can run your code like line by line and not have to go through, rerun the whole script. And here I can see the output. I don't even need to print salaries or anything like that. We can see about 5,000 rows of data here, 11 columns. Things that jump out to me is I want to check out experience level, job title, and then company location. And we can even check out remote ratio as well. and company size. So those will be some good things for us to go through and just do some EDA here, exploratory data analysis. And then another video we'll go through and try to train a model based off of this. Okay, so let's go ahead and start by looking at experience level. So how should we visualize salary versus experience level? Well, I'm going to use focus on this column here, salary in USD, mainly because it's going to give us a standard unit here versus experience level. What jumps out to me, there's going to be 4 different possible values for experience level. I think if we do a box plot here, that will give us a good representation here. So let's go ahead and import some of our visualization libraries. We'll go ahead and import matplotlib.pyplot as PLT, and we'll get Seaborn's SNS. And then when you're using pyplot, you need to, in your notebook, specify that you want to render these visualizations in line. And let's go ahead and create a, let's do a box plot here. Go sns.boxplot, and we'll set salaries as the data, and then X, my X column is going to be experience level, and then our Y column is going to be a salary in USD. All right. So right off the bat, we can see that this kind of gives us the expected distribution, what we would expect. Entry-level salaries, you're going to have kind of a lower overall distribution, mid-level, higher up, senior, and then executive. And just with any data set, you're going to notice, hey, there are kind of some outliers here. Obviously, you'll find, in some cases, an entry-level making higher than a mid-level. Bound to happen. But overall, you'll see the trends, more levels of experience, higher levels of experience, better average salaries there, which makes sense. But just a couple interesting things here. There's this mid-level employee who's making more than everyone else. Let's go ahead and even try to find that employee. Salaries at experience level equals MI. I'll try to find the max here. And we get this sales data analyst whose salary in USD is $750,000. Looks like overall salary, I'm not sure how this differs, but they've got like a 8.5 million salary, but salaries in USD for some reason, even though it shows their currency is USD, 750,000. So sales data analyst, that's the job, that's the golden ticket there because of that one individual. All right. Okay, let's keep moving along here. Let's look at, for example, let's see how many different job titles there are. When I look at something with job titles always kind of stick out to me because especially within the data science, there's kind of this tendency to call, things that, occupations that do the same thing by different names. That kind of muddies the waters. And so let's try and just get an idea of how many different of these 5,000 titles, these 5,000 jobs have different titles. So what we can do here is we can just look at salaries at job title, and we can run a value counts on that. Okay, you can see here at the bottom there are 123, which is not too bad out of 5,000 jobs, and we can even see that there's kind of a heavy distribution between these 4 titles here. So something down the road you may want to do is clean that up and just say, well, I just want these 4 job titles here, and then look at the salaries between those 4 things. But we do also notice there's a good, healthy distribution of things that only have, one job title there. And that doesn't do us a lot of good for comparisons because you can just, if you go in, say you're using this kind of data to argue or negotiate for a salary increase, if you were to go and say, hey, well, the data shows that one other guy with this same job title has this salary, this one sales data analyst has, a big fat salary, therefore give me that. Might not hold a lot of sway. But if you can say, well, on average, I know 1,000 other data scientists, and I'd like to be put more in line with what they're earning, that argument holds a little bit more sway there. All right. Let's see here. Actually, I think it would be interesting to get an idea of how many of these salaries do only have one title that accounts for it here. So in order to get that, and there's probably going to be an easier way. Somebody, if you have an easier way, leave it in the comments here. But what I'm going to do here is I'm going to create a new data frame based off of value counts here. And then from there, at that one. What we did there is we created a separate data frame just for the value counts here off job title, and then we're going to isolate those by where the count is 1 here. And we can use our little handy dandy length there. So there's 29 jobs where there's only 1. Let's go ahead and do this. Let's get it where there's less than 10 out of our data set there. That's a little bit more substantial. There's about 88 different jobs where there's only 10 out of 5,000 with that job title. Now, that could be we're sampling from a bad data set or from specific types. But in that case, we might look to exclude that. We're not going to do that right now, though. But I do want to let's go ahead and check out how many different countries we're sampling salaries from. Different countries. We're going to do value counts here. And we can see that, out of 5,000, about 4,400 are in the United States. With a few, a few other countries there. So if we wanted to, and I think I will do this, it's tough to argue for salary and say, well, people in Singapore are making this amount of money. Yeah, that's kind of a tough sell there. So let's go ahead and just mutate our salaries in place here. All right, and that should do it for us. Just to verify that, this should just return 1. And yeah, we've just narrowed this down all to U.S. countries, or U.S. companies here. All right, last thing that I want to do here before we finish up is let's go ahead and look at the different job titles. We've already done that, but let's go ahead and take a comparison of the actual salaries based on job titles. And maybe see if we can get some sort of visualization there. I'm thinking about a box plot here, but the problem is going to be that we're going to have, quite a few, different, it's going to be quite a terrible visualization, and I'll just show you why. If we do a box plot, not a boxing plot, here, and we do salaries as their data, and our X is going to equal job title, with our Y equals salaries in USD. We're going to see, that's giving us problems because I think it's just salary in USD. Yeah, that's really hard for us to read there. We could try to widen this, but what if instead, what if we narrow down our data set here and just take a subset of data where the job title is maybe one of those 4 that are our most popular. And those are going to be, let's go ahead and insert a cell here. That's going to be data engineer, data scientist, and we'll say data analyst, and machine learning engineer. Okay. And let's go, oops. I apologize for jumping around so quick here. Aside from that, we'll go ahead and create a separate data frame here. We'll say top for salaries df equals, and then what we can do here is we can just going to create a subset here. Job title dot is in top 4. All right, so that creates a separate data frame for us here, where we've just found the salaries where the job title was one of those 4. And from here, let's see, I can go ahead and try to rerun this with top 4 salaries df, and boom, that cleans it up a lot for us. And let's go ahead and set figure big size, and we'll get this to be like maybe a 10 and 4. All right, that gives us a little bit of a better distribution here, better visualization. And this shows us a little bit more of a trend. Data analyst is a bit on the lower spectrum. Data scientist, data engineer, those two really seem fairly even to me. And if you were to ask me the difference, I'd be hard pressed to really define clear differences between a data scientist and a data engineer. And then a machine learning engineer, that's kind of a subset specialization. You'll see that has commands a little bit of a higher salary there, which is about what I'd expect. Okay, so I've gone through just a quick, quick EDA process here, evaluating different correlations here on this data set, getting some information, cleaning up our data a little bit, and getting some insights. And so in our next video, we'll go ahead and train a model. Come back for that one. Thank you.